Okay, let's move on to item number 11. In a standard deck of 52 cards, what is the probability of picking a card that is either a king or a black card? Is it 1/2, 7 over 13, 27 over 52, or 15 over 26? Take note, what is asked here is or. If you could recall in our statistics, or means union. The end could be your intersection. And the formula, if ever the regardless if your intersection is empty or not, is probability of A or B is equal to the probability of A plus the probability of B minus the probability of their intersection of A and B. So from here, it becomes the probability A is the probability of having king, and B is the probability of having black card. So we have here probability of king or black is the same as the probability of king plus the probability of black minus the probability of having a black king card. We know that in a deck of cards, I hope you are familiar, we have 4 kings. King of hearts, spades, diamonds, and clubs. In 26 of them, in 52 of them, half of them are actually black. These are the 13 spades and the 13 clubs. That's why plus 26 over 52. Minus, how come I subtracted 2 over 52? Because there are 2 black kings, which is in fact their intersection. We have a king of spades and king of clubs. And so what do we do is we simplify. Since they are similar fractions, just copy the common denominator. 4 plus 26, that's 30, minus 2, that's 28. So we have 28 over 52, which simplifies to 7 over 13, which is the probability of getting a king or a black card. Letter B is our answer here. Number 12. Let's see. A natural number in the set A with 1 from 1, 2, 3 until 100 is chosen. What is the probability that the number picked is a perfect square and a perfect cube? Is it 3 over 25, 1 over 25, 3 over 50, or 1 over 50? What do you think? So be careful, as what I said earlier, and entails intersection. So what do you think is the intersection of this? What numbers from 1 to 100 is both a perfect square and a perfect cube? These are 1 and 64. There are only 2 of them. 1 is 1 squared or 1 cubed. For 64, it's 8 squared or 4 cubed. And no more, that's for sure. And there are 2 of them out of the 100 numbers. So the probability is 2 over 100, which is 1 over 50. Letter D. I hope you got it correctly. Number 13. 5 red balls and 4 green balls are placed inside a container. All the balls are identical in all aspects except for color. Balls are drawn without replacement, meaning to say, if that ball is taken out, if you got the ball, then you will remove it out of the container and will no longer be drawn or part of the next draw. What is the probability that the first 2 balls drawn are red and the last 2 balls are green? Which of these probabilities do you think is correct? We'll see. So from here, we have 5 red and 4 green balls. The probability, it says there that the first 2 picks are red. So the probability of having the first pick of red is 5/9. How come 9? Because 5 plus 4, that's 9 objects in all. So 5/9. If you got the red ball already, which means there are 8 of them left. And since one red ball is already taken out, then there will be 4 red balls for the next picking. That's why the probability that you will pick a red ball in the next draw is 4/8. Now, the next 2 picks are green. So that now that you have picked 2 balls, that's why there are 7 of them left. And the third pick should be green. That's why there are 4 green. So 4/7. And if you pick the green already, there will be 6 left in the container. And then 3 green balls will be left. Therefore, 3/6 is the probability of picking a green ball in your fourth pick. And if you multiply everything, because they are dependent events. Why dependent events? Because their probabilities are influenced by previous occurrences. And that you got 5/63. And that is letter C. Okay. I hope you got this as well. 14. How many subsets does the set A with elements 1, 2, 3, 4, 5, 6, 7, 8 have? Is it 128, 256, 512, or 1024? In set theory, a set with n elements has 2n subsets. That is, since our set A here has 8 elements, and following this formula, then its number of subsets is 2^8, which is 256. Letter B is the correct answer here. And what is also, we have to remember this, that in these 256 subsets, the null set and the given set are already parts of it. Okay? So B is the correct answer here. 15. A certain class of students were surveyed if they like cats and or dogs. 47% likes dogs, while 37 of them likes cats. If the probability that they like cats or dogs is 75%, what is the probability in percent that they like cats and dogs? Is it 9, 84, 93, or 100? What do you think? So to answer this question, we have to go back here. Earlier, so we are talking, it's the same formula earlier with the probability, because in this case, the probability that they like cats is A, and the probability that they like dogs is B. So A or B is 75% based on the problem. They like cats is 47%. They like dogs is 37%. And what we are looking for here is probability of A and B. And to solve for it, we will add both sides by the probability of A and B. We will add. And we will subtract both sides by 75%. And in doing such, we have probability of A and B equals 47% plus 37% minus 75%. And 47 plus 37 minus 75 is 9. Therefore, the probability for this to happen, that they like cats and dogs, is letter A, 9%. 16. The probability that a student is part of the honor roll is 37 hundredths, while the probability that he is male is 23 hundredths. What is the probability that he is a male honor student? Is it A, B, C, or D? What do you think? So for this case, it says there, a male honor student. And this means that it should be male and honor student at the same time. That's why it entails intersection. And so to do that, the probability that it is of A and B is you have to multiply their respective probabilities, individual probabilities. And that the probability of honor and male is equal to the probability that that person is an honor student and that that person is male. For such, we have 3700s times 2300s, which is letter A. That is 0.0851. I hope you got them correctly, and God bless for the next items. Number 17. In a certain data set, quartile 1 is 13 and 90th percentile is 31. Approximately, what percent of data is between Q1 and P90? Is it 18, 65, 79, or 89? So to answer this question, we have to remember the concept of measures of position. When we speak about quartile 1 here, which is 13, implies that approximately 25% got lower than the score, which is 13. And if you have P90 or 90th percentile of 31, implies that approximately 90% got lower than 31. And if you wanted to get the number of the percent that belongs between 31 and 13, 13 and 31 approximately, what you have to do is you have to subtract these 2%. And therefore, approximately 90% minus 25% equals 65% of the scores are between Q1 and P90. Letter B. Okay. I hope you got them. Number 18. Which of the following has a different value from the rest? Is it Q2, P50, D5, or your mean? And if you answered mean, letter D, you got it correctly. How come? Because Q2, P50, and D5 are actually equal to your median. And take note that in a certain data set, mean is not necessarily equal to your median unless you are having a normal or standard normal curve. Hence, letter D is the correct answer here. Number 19. Calculate quartile 1 of 1, 2, 4, 5, 7, 8, 8, 8, 9, 10, and 15. Is it 4, 5, 8, or 9? So usually, if you would like to compute 4 quartiles, it's better that the numbers involved are already in ascending order or descending order. But in my case, I prefer it to be in ascending order, meaning from least to greatest. But what is good is that the numbers provided here are already in ascending form. And you could see that there are 11 scores. And since 11 is an odd number, then 11 plus 1 divided by 2, that's 6. The 6th score corresponds to your median. So from the left, we have 1, 2, 3, 4, 5, 6. That's why I placed here the 8 in red to indicate that 8 is our median. And remember, as what I said in the previous item, Q2 and the median are just equal to one another. And to get quartile 1, and by the way, all the numbers, the numbers smaller here, no, or to the right, to the left rather of your median, these belong to the bottom half or the lower half or the lower 50%. And all of the scores at the right here belong to the upper half or the upper 50%. And when we speak about quartile 1 or Q1, it is the median of all the numbers in the lower half. Hence, what we need to do is find the median of the lower half scores, which are 1, 2, 4, 5, and 7. And what's the median of 1, 2, 4, 5, and 7? Because there are 5 scores, that is, it's the 5 plus 1 all over 2. That's the third score, which is, in this case, 4. Hence, quartile 1 is 4, and that letter A is the correct answer here. And if you could see, if you would like to solve for quartile 3, it's the median of the upper half, which is 9. But anyway, we are only required of quartile 1. So it has to be 4. 20. You are not after of the order of elements you have taken. This involves permutation, curation, combination, or substitution. What do you think? The correct answer is combination. In combination, as long as you have all the objects and you selected them, their order of appearance does not matter. However, for permutation, order matters. And by the way, options B and D are just included there. And in fact, the answer here is letter C. I hope you are having a great time so far. So far, so good.